Hello, everybody. So what we're going to look at today is going to be section 13.2 again, and we're just going to keep going, right? So from where we were last time, we will pick up from there. So I copy pasted this definition of a finite state machine from the previous lecture notes. We'll just briefly mention the stuff in here. So a finite state machine, if you remember, has a bunch of things to it, right? So it has a list of states. Like for the vending machine, it was the number of, well, not the number of, it was basically how much money there was in there, right? So we had 0, 1, 2, 3, 4, 5, 6 for a total of 7 states. And each one was 0 cents, 5 cents, 10 cents, 15 cents, etc., deposited in the machine. So a number of states. You have all of the possible inputs. The inputs could be anything. This is just a list of all of the inputs. You have an output alphabet, which is kind of the same thing, but it's a list of all of the possible outputs that your state machine can have. Then you have a function, that's for every current state and every input, we need to define the new state, right? Like, so if you have 5 cents in the machine and you deposit 10 cents, that moves you to 15 cents. Well, 15 cents is like state 3. So the function that tells you that is called f, in this definition. You have basically the same thing, but instead of for every state and input defining the next state, you also have to, for every state and input, you have to define a possible output. And of course, a possible output could be nothing. It was mostly in the vending machine, right? Um, the vending machine only ever has, it only does something when there's enough money in the machine. And then also you have to specify where the state starts. And then that's everything for the finite state machine with output. So so that's where we were. And so what I want to do is I want to show you a another way to represent a finite state machine. So we looked at a table last time. So this is going to be, let's see here. Okay, example one. Um, yeah, okay. That's fine. Okay, so state, example two, state diagram. All right. So this is going to be example one. Let me get a color to write with. Example one. Okay. So here is what are they going to call a state table for a finite state machine. And before I give you the table, I'm going to tell you kind of all of this stuff for it. So what do we need? So if I say S equals, and it's kind of just a set here, so I'm just listing them, S0, S1, S2, is that enough? S3. All right, so we've got 4 states, S0 through S3. We have possible inputs, and in this case, the inputs are just 0 and 1. Now, what do those represent? I don't know. I don't care, right? We don't need to know that in order to write stuff out about this finite state machine. Now, what are the outputs? Also 0 and 1. Okay, so we got the states, the inputs, the output. We need the F and the G. Well, we're not going to like list out the F and the G anyway. We're going to show the F and the G in the table. So F and G are shown in the table. That's how we did it for vending machine anyway. So we got the F and the G, and then we need a starting state. Um, and I don't even think they say it, but you know, we called S0 S0 because that was the starting state. So let's just say S0 is the starting state. S0 is the starting state. All right. So there's some stuff. Now, what's the table look like? Well, we don't know the F and the G. I mean, we do know it because it's in the book, but you couldn't guess it, right? You can't look at what I have written down right here and say, I know what the table looks like. I know what all the values are. That's not possible. But you know, we know some stuff about the table. So the way one of these tables has to look is we've got first we've got the state that we have to keep track of. And we know that for the state, we're going to have just S0, S1, S2, S3. Those are going to be our possible states. So I put those there. And then we know that we have our inputs and outputs, but there's basically two sections here. So the F, let me move this slightly here. I'm just going to move this over here out of the way. Okay. So your F, right, is going to be based on these inputs. And what are the possible inputs? The possible inputs are according to the alphabet up here, 0 and 1. These are your possible inputs. So you put, okay, we could have a 0 and we could have a 1. Okay. And then we're going to have our G. And for the G, we need to know our possible inputs, which are also 0 and 1. And that should be enough actually to do our table. So we don't actually need this line to be so long. Okay, so there we go. So this much of the table you could already write just based on what we have up here, right? Because you've got your states, which we put here, your inputs, which are here, your inputs, which are here, right? These outputs are 0 and 1, but these aren't the outputs. These aren't the outputs. These are inputs and inputs. The outputs go here, right? Because what you've got is this first section is going to tell you the state transitions. And this right here is going to tell you the outputs. Okay. So, what does this state machine look like? Well, there's no way to predict it, right? We just have to draw it based on, what they told us. So they say it goes S1, S0, and then S3, S0, and then S1, S2, and then S2, S1. All right. And then your output are going to be zeros and ones, and we'll fill those in. So like 1, 0. Okay. 1, 1, 0, 1, and 0, 0. Now, again, I know I've said it a bunch of times, but I'll say it again. There was no way for you to guess at what those numbers were. There was no methodology. I was just copying that from the book. This is just from the book, this example. Okay. And there we go. There's our state table. And so, like, for example, um, you would be able to use this table to answer questions like this. So you'd be able to say, like, let's see, if the current state is, let's say, S1, and the input is 1, what is the output and the next state. I'll say what is the next state and the output, right? So the book will ask you questions like that. And so how would you do it? What you would do is you would say, okay, the current state is S1. Here's S1, okay? And the input is 1. So here's 1. So that's going to mean that in order to get the next state, you just come over here, come down here, and it's going to be S0, right? If you're in S1 and the input is 1, then this is going to be your, what's it called? This is going to be your next state. So next state is S0, and then the output is, well, same thing, right? So we still have the S1 and the 1, so we'd be down here. So it looks like the output's going to be 1 as well. Okay, and so that's how you read that state diagram. If you know the current state and you know the input, you'd be able to tell me what the next state is and what the output is. All right. So hopefully we have an understanding of this from that long vending machine example in the previous lecture, or from this right here. Now, this is not the only way to give you the same information though. So what we want to be able to do is we want to be able to represent the same information as a state diagram. Represent the same information as a state diagram. Okay, so what's a state diagram? So a state diagram is basically like a flow chart. Okay, so what you do for a state diagram is you take all of your states and you put them in circles. It's like a flow chart. So, for example, here's a circle. I'm going to copy paste this 4 times. Duplicate. Duplicate. Now, it doesn't actually matter where you put them. Oops. So like, sorry, you can't see what I'm doing, but I'm just kind of moving them around. No. All right. That was too much trouble. Okay, so you've got 4 circles, right? And these 4 circles are your states. So it doesn't matter where you put them. You just put them somewhere. So we got S0, S1. I'll put S2 down here, and I'll put S3 up here. That's pretty much where they put them in the book. It's a little bit different, but there you go. So you put all your states there. And then what you want to do is you need to label how you go from one state to another state. So for example, let's look at, the one that we just wrote down, right? If your current state is S1, then the possibilities are you move to S3 and you move to S0, right? Based on the input that you get. So you either go to S3 or you go to S0. So that would mean down here, what you're going to see is that from S1, there's going to be an arrow that goes to S3. It's going to be an arrow that goes to S3. I want a nice curve. Arrow that goes to S3. But then there's also going to be an arrow that goes to, what was the other one? S0. So there's going to be one that goes there. Now, you have to label these somehow, right? Like I can see that S1 goes to S3 and S1 goes to S0 with those arrows, but I can't see under what circumstances that is the case. And so what you actually have to do is you have to label the input and the output on that line that you just put. So like, for example, here, from S1 to S3. Oops, sorry. From S1 to S3, what input takes you from S1 to S3? The input is 0, right? And so you have to put on S1 to S3, you label it with a 0 because that was the input that takes you from S1 to S3 was input 0. So you put that there. That's the input. But also, where are we going to label the output? Because if you do have S1 and 0, you go to S3, which you can see here. But if you have S1 and 0, you also have an output of 1. So where do you put that? And the way they do it is they actually just label it like this. Okay, so the first one is the input for the transition, and then the second one is the output. So just like as a note here, right? This would be saying, so input of 0 to S1 moves you to S3 and gives an output of 1. And so that's what that 0, 1 means. So the arrow means S1 to S3, and then the 0, 1 is the input that does it and the output that you get. Okay, so if we do the same thing for the other one that we've got there, S1 to S0, right? This arrow right here, S1 to S0, is going to be when S1 to S0 was when the input was 1, and also the output is 1. So it should be labeled 1, 1. Right. So there you go. There's 2 of them on the list. Well, now you've got to do all of the others. So, I mean, I just did kind of a random row there, but we've got a lot of other arrows to draw. Well, what, like 8? No, 6 others to draw, 8 total. Okay, so let's do this. So, for example, our first one, our first row here, we have S0 will take you to S1 if the input is 0. So S0 to S1. So S0 will take you to S1, and it will do S0 to S1 if the input is 0, and S0 to S1 with the 0 input is going to be S0 with the 0 input is going to give you an output of 1. So that's a 0, 1. Okay, so that's one of them. Now we have to do S0 to S0, right? Or yeah, S0 with an input of 1. So S0 with an input of 1 gives you an output of S0. So that's S0 to S0. So you draw that actually as a loop like that. S0 takes you to S0. And what input does that? That was input 1, right? Input 1 does this. Also, what's the output for that? Well, S0 and 1, 1 is here, gives you an output of 0. So that's 1, 0 there. All right, so that's your first row. Second row. Well, we actually did the second row already, didn't we? So we're done with the second row. So third row. So we've got an S2 to S1 transition with an input of 0. So S2 to S1, input 0. So S2 to S1, oops, S2 to S1, the input was 0. What's the output? So S2 to S1, output 0. Like that. Okay, what's next? We've also got an S2 to S2. We know what that looks like. That must have been for the input of 1, right? Yeah, S2 to S2 was input 1. So that's input 1. And what was the output for S2, S2? Right, S2, 1. So that's a 1, 1. All right, last row. So for our last row, we got S3 to S2. That's S3 to S2, like that. That was for an input of 0, right? And then what's the output? Right, remember this is all input 0, like input 0, input 1, input 0, input 1. So, so I know this is a 0 input, and also I see a 0 output. So that's a 0, 0. And then what's left? Last one, S3 to S1. Where's S? Okay, so S3 to S1 is like that. And S3 to S1, and we need, that's an input of 1 and an output of 0, it looks like. Okay. So that's, I think that's all of them. And so that information right there that's in that table is exactly the same information that is in the state table. Now, to my mind, it just takes a lot more effort to draw this, but maybe drawing this picture actually gives you a better understanding of what's going on, because you can see like it's easier to see kind of like multiple length transitions. Not that doesn't make sense, but like it's easy to see what happens over time with one of these diagrams, because like you'd be able to look like, oh, okay, well, if you start in S0, we could come back to S0 and then go over to S1 and then go over to S3 and then come back to S1 and then come back to S0, just following arrows, right? Um, Whereas in this form, it's a little bit harder to see that, because you'd have to say like, oh, okay, so S0 could go to S1, but then you're in S1. S1 could go to S3, so you're in S3. S3 could go back to S1, so we're here. S1 could go back to S0, so you're here. You can trace your way through the states that way, but the diagram is definitely more visual if you're oriented that way. So yeah, two things: state tables and state diagrams. Okay, and yeah, so you need to kind of be able to um, draw both of them. Basically, is what it comes down to. So let's see if I can find something else to do here. Maybe we should do a state table to a state. Sorry, a state diagram to a state table. Um, let's just pick one from the homework. So let's say, okay, so I'm not going to draw this as nicely. There's S0. It's 1. S2. S3. We got this. That's 0, 1. We got this. That's 0, 1. We've got this. That's 0, 1. We've got this. That is 1, 0. We've got, oops. Sure, why not? S2 to S3, 0, 0. We've got S3 to S1, 1, 1. Sorry, I said that wrong, but I wrote it right. S3 to S2. And then we got we got here to here, which is 1, 0. And then we've got here to here, which is 1, 0. Okay. Oh, and also they do this. So there's kind of a new thing. They put an arrow like this and they go start. Okay. So they're telling you that you start in S0. I think they're all going to start in S0, right? Because by definition, they said S0 was the starting state. So whatever state you want to start in, you just call S0, and then, you'll always be starting in S0. But there you go. So here's a diagram, right? And this is from like problem 2 in the book, 2A. And what we need to do is we need to give the state table for this state diagram. So give the state table for this state diagram. All right. And so that's what we need to do. It's not going to be that hard. We just kind of want to make sure we understand how this information goes back and forth between the two ways. So again, like for a table, we're going to go, we have states, and you just go S0, S1, S2, S3, like that. We're going to have our, remember F, it's going to be, we're going to have 0 and 1. Those are inputs, remember, not outputs. You got your G, which is also going to have inputs of 0 and 1, right? And so these are going to be your outputs here. And these are going to be your state transitions. And writing those words there is not part of this. It's just to remind us of what we're doing, because we're still new at it. Okay, so you just start filling out this table wherever you want. I mean, you should start at the beginning probably. But so let's do this. Let me maybe get a different color here. Blue, light blue. Okay, so like for example, this top line right here, this says you go from S0 to S1 if the input is 0. So S0 to S1 if the input is 0. That'd be right there, right? S0 input 0 gives you to S1. Okay, but it also does another thing. It also says S0 to S1 if the input is 0 and then the output is 1. So you need to put a 1 here, right? The corresponding box in G. Okay, so we did this one. If we're going to continue on with that 0, we'll need the other arrow that comes out of S0. So this one, right? Not this one, because this is S1 to S0. We want S0 to, in this case, S2. So we got S2. So that would be, we go from S0 to S2 with the input 1. So that's like that. And then what's the output from here to here? Output is 0. So there you go. All right, row's gone, or done. Let's go to S1. So as S1 does two things. It goes back to S0 and it also goes down to S3. So let's go S1 to S0. So S1 to S0 is the input 0. So S1 to S0 is input 0. So that's here, right? Because these are, remember, these are the inputs. These are the inputs. All right. And S0 to S2. No, sorry, what are we doing? Oh, S1 back to S0 was input 0, output 1. All right. And then also we have S1 to S3, which is for input 1. So input 1 is right here. And S1 to S3, oops. S1 to S3 comes with an output of 0. So like that. Now notice too that as I'm going through this, that you're never going to be writing something in the same box twice. So like, for example, like if I got confused, right, I might go like, S3 to S2, that's a 1. And then like I come here and go, oh wait, isn't there something already in that box? Well, that would tell you that something's wrong, right? You should never be trying to write something in the same box twice. Every line corresponds to one box, or actually two boxes. But there's 1, 2, 3, 4, 5, 6, 7, 8 positions. in this first group, and then there's the equivalent positions in the second group. You'll never have to write over one with something else. Okay, S2. So we got S2, S2 to S0. That's if input is 1. So that's actually that box. And then from S2 to S0, the output is 0. So that's there. And then you got, what's the other S2? The other S2 is S2 to S3. There it is. And S2 to S3, that's for input 0, which we saw, and the output is 0, which we will write. What? Already was 3. Okay. Last one, S3. So S3. So we got S3 goes up to S1. And that was if the input is 0. So I drew that in the right place. And the output is 1. Right there. And then for the last one, we got S3 to S2. It's there. And that was if the input was 1. So I drew it in the right place. And the output is also 1. So we have that. Okay. And so that's our table. So we got a diagram up here. That's a diagram. This is a table. All right. So, make sure you know which one's which. And so you do the right one if you're asked to make one on homework or something. All right. So those are, state tables and state transitions. Let me see what else we can do in here. Just don't like that. Yeah, okay. I think what I will do is just kind of say a couple things about not the homework, but about just kind of state machines in general here. So, like, what would these be used for? Um, right, we already saw like the vending machine in the previous lecture, but there's other stuff, right, that you could use them for. Like another like really common use for these is basic behavior of like enemies in a game, right? Like enemy behavior in a game, or just also could be NPC behavior. How would that work? Well, what you could have for your states is your states could be like S0 could be like an idle state where you just have an enemy standing there. And then like S1, maybe S1 could be like a attacking state where the enemy is actively attacking you, like shooting. And then you could have like an S2 state where the enemy's not idle, the enemy's not attacking you. Maybe the enemy knows you're there, but it doesn't know where you are. So it could be looking for you. So it could be like searching, something like that. And that's actually pretty common. If you do play video games, you probably have seen like those behaviors, right? Where like, oh, okay, yeah, the enemy stands there. When they see me, they shoot. When they can't see me, they say, "Where'd he go?" And then they like walk around looking, right? So and that's just kind of this basic three states kind of a thing here. And then for your inputs, right? So these would be your states, obviously. What would your inputs look like? for this? Well, the inputs to the state machine would just be what information does the state machine going to need in order to know what state to move you into. So you could have like I don't know what to call them, but like maybe one input is S, and S is um, enemy can see you. How would you know that? Maybe like line of sight or something. There's no objects between you and them. So enemy can see the player, right? Probably need that. That's going to control a lot of it, but also in order to go from searching back to idle, you might need um, like T, where T is going to be like the time since the last time the enemy saw you, for example. Time since enemy has seen you. And like maybe we go like this is like you know 0 to what do we need? Like maybe it would be like number of seconds, but you don't want to have like every possible you don't want to go like 0 1 second 2 second 3 second up to like 30 seconds, because if you did that, then when you write your state table, instead of having 0 and 1, you would have like 0 through 30. So I'd have to draw 60 columns just to do those if I did like 1 through 30. um so maybe what you would do is you'd say like time since enemy has seen you, and you would just have like um less than 30 seconds or greater than equal 30 seconds. Just two inputs there. Um, that would be that'd be easier. Um, well, maybe I wouldn't need that, right? Like T, because I would have had. Um, no, yeah, we would have needed it. Um, so then maybe like this. Sorry, this is probably not the way to do it. Not time since the enemy has seen you. Rather, we would do it this way. Um, so like this would be one if um, no T if more than 30 seconds since the enemy last saw you. Right. So I mean, there's some thinking involved in order to figure out how to make this a uh, in order to figure out how to make this a state machine. So we got our states, we have our inputs. What would our outputs be? Well, I mean, you don't really need outputs, um, but like the output, like maybe would be like the change in behavior. Um, so maybe we'll just say that you know our outputs are what the enemy is doing. So like maybe like standing, um, walking, and shooting. Maybe those are um, they're not really outputs, right? You could think of those as like part of the states, but I'm just gonna put them as outputs. Otherwise, maybe our outputs would be nothing. So let's just do that. Um, all right. So let's see here. Actually, yeah, no, that's fine. So also these are kind of the inputs are still a little bit weird here. You've got enemy can see you, and then more than 30 seconds has passed since the enemy last saw you. Um, so these are mutually exclusive, right? Like if it's been more than 30 seconds, then obviously the enemy can't see you right now because it's been more than 30 seconds. And if the enemy can see the player, then um, then obviously it has been more than 30 seconds. We're going to need one more input. We're going to need less than 30 seconds. Um, so let's call them like T1 for more than 30 seconds, and then like T2 less than 30 seconds. Actually, let's change that. Less than. Since enemy saw you. All right. Yeah, that's better. We're going to need that because we always want to have an input. And so we need can see you now, can't see you, but it's been less than 30 seconds, and can't see you and it's been more than 30 seconds. Those are the three states. Okay. So what would this look like? Right? So the idea is you can do it in a table or you can do it diagram. Um, let's do it in a table, I guess. So for the table, we got our oops, our states. So we're going to have S0, S1, S2, right? We're going to have our F, which is we're going to have our inputs. What are our inputs? Our possible inputs are like S, T1, T2, just because that's how I did them. And then our G, again, our inputs are going to be S, T1, T2. All right, so there's our table. Now, how does this work? So we got to think about how to do it because we didn't actually say. But so let me label these a little better. So this is idle, right? This is idle. What's S1? S1 is attacking. And then S2 is going to be searching, looking for you. All right. So let's figure this out. So here's the idea. Like how should this AI behave? Well, if you are in the idle state and the enemy can see you, then the enemy should change into an attacking state, right? If they can see you, they're going to start attacking. So what's the attacking state? It's state S1, right? So that would be saying if the enemy sees you, it attacks, moves from idle to attack. Now, what would the output there be? Well, I say, shoot. We didn't really need that, but, just to do something. Um, start shooting. You could just leave off the entire output table because we don't really need that, but whatever. Okay, so we got one. Now, but what if you are in the idle state and it's been less than 30 seconds have passed since you've seen them? Now, that probably is actually never going to happen, but if you're in idle and it's been less than 30 seconds, I mean, probably you're just going to stay in idle. If you're in idle and you can't see and the enemy can't see you, the enemy's probably going to stay idle if it's idle and can't see you. So S0 and S0 there. And then what would the output be? Probably stand, and that would be stand. So I'm using the output just to show like behavior. I know that idle, attack, search kind of label that, but yeah, whatever. All right, so shoot, stand, stand. Now, what if you're in the attacking state? Well, if you are currently in the attacking state and you see the player, you should still be shooting. You should stay in the attacking state. So S1 to S1. Okay. And what would the output be? Well, it'd be shoot. Okay. Now, um, what are we going to do? So if you're in the attacking state, and you're in T1, or you apply input T1. T1 is less than 30 seconds passed since the enemy last saw you. So um, you're attacked, like the enemy's attacking you, but you hide. What's the enemy going to do? Well, I mean, depending on how you do this, the enemy's probably going to, like, either it's going to stay attacking you or it's going to change into searching. Let's just say it changes into searching state, right? As soon as it can't see you, you go into searching state, like that. Okay. Now, what if you're in the attacking state and it's been more than 30 seconds since the enemy last saw you? Well, that's probably impossible because it probably has to go, it'll probably change you to S2 when you, like, if it hasn't seen you for 10 seconds, it will change to the searching state. So it'll never get to more than 30 seconds gone by in the attacking state. But we can still say what to do if that ever happens, and then your code won't have a bug if somehow some crazy thing happens. So we'll say no matter what, those will both go to S2. And those are searching. So what happens in the searching state? Well, it probably walks around looking for you. You mean it probably does a lot more. Like it probably, um, you know, that's where they say, "I'll find you," and that kind of stuff. But we'll just say walk. Okay. Now, searching state. What are we doing? Now, for the searching state, if you're in the searching state and you see the player, you're going to immediately go back into the attacking state. So you can start shooting again. Shoot. Okay. But if you're in the searching state and it's been less than 30 seconds have passed since you've seen the player, you're still going to stay in the searching state. What that's going to do is that's going to let the AI look for you for 30 seconds, right? Because what's going to happen is it's attacking you. It can't see you. It can't see you, so it immediately turns into the searching state. Once you're in the searching state, you want to stay in the searching state for 30 seconds looking for the player before you go back to idle. So that's why we have this less than 30, greater than 30. So that way you can stay in the searching state for 30 seconds. Now, what do you do in the searching state? You walk around. Keep writing wait. Okay. Last thing here. If you're in the searching state and T2 state or input comes up, which is T2 is more than 30 seconds passed, well, after 30 seconds have passed in the searching state, you're going to give up searching. And when you give up searching, you go back to the idle state. Like that, which means you go back to stand behavior. Okay. And so that'd be a very simple enemy AI. It sees you and it shoots. When it stops seeing you, it looks around for you for 30 seconds. After 30 seconds, then it goes back to idle. And lots of AIs work exactly like this in video games. So very simple, easy to do. You can see what variables you would need. You would just need basically a variable to say, can see the player right now, like a function to test that. And you would need a variable to keep track of time, where it would be how long has it been since it saw you, which really you probably wouldn't want to implement this way. You would probably have like a timer. Like probably what would happen is as soon as the enemy can't see you, it would probably start a timer with 30 seconds on it, and it would wait for the timer to expire, and that would trigger the going back to idle. Rather than counting up to 30, I would say you count down to 30. And that would just be so that, you don't have a timer that keeps counting up forever. Um, Usually a bad idea, right? Just to keep adding to a variable over and over way after you need it. Okay, so there you go. So um, there's a table. Okay, so that's going to be it for right now. Next lecture is going to be your homework that's going to be due during finals week.